right, day 6. Conditional probability. We've been talking about independent events. Now we're going to talk about conditional probability. So if your parents give you a condition, something that has to happen before something else that can occur, keep that in mind. A compound probability is when 2 or more events happen in a sequence. When one probability is determined after an earlier event has already occurred, it is called a conditional probability. A conditional probability is notated as this. Probability of A, and there's a line, a vertical line, B, which states that the probability of event A given that event B has already occurred. Alright? So A, given that B has already occurred. The formula for calculating is as follows. Probability of A, given B has occurred, is the probability of A and B divided by just the probability of B, the one that has already occurred. So, we've already done this before. Probability of A is 0.6. The probability of A and B is 0.24. So if we look back up here, here's probability of both. Here's probability of the given event. Here's probability of both, probability of the given event. So since A is given, that's going to be our second letter. So we're trying to determine the probability of B given A. So again, on top, the probability of A and B. And on the bottom, the probability given to us, A, equals 0.4. Over here, we're given B this time, which means this could be our second letter. So it's probability of A given B. 0.12 on the top, divided by 0.4 is 0.3. Conditional probability independence. Earlier we found out that if 2 events are independent of each other, then the probability of A and B is the probability of A individually times the probability of B. Notice that because the 2 events were independent, the second event's probability was not impacted by the first. Thus, when we were dealing with 2 independent events, the conditional probabilities are also not affected by the other event occurring previously. Thus, the probability of A given B is equal to the probability of A. Probability of B given A is equal to the probability of B. Because the fact that one has occurred first makes no impact on the probability of the second. So, example 1, flipping a coin and then picking a marble from a bag are 2 independent events. So, the bag of marbles contains 2 purple, 1 green, and 2 orange. Again, remember we always say that's 5. What's the probability of getting ahead if you knew that a purple marble had been selected first? So, what's the probability of ahead given a purple? So, in the previous notes, probability of ahead is 1 out of 2. probability of a purple is 2 out of 5. And probability of getting both is just 1/2 times 2/5, which equals 2/10. But now we're talking about a head, given that we got a purple first. So mathematically, what we have to do is we have to take the 2/10 right there, head and purple, divided by the given, which is purple, which is 2/5 on the bottom. So that's where we have 2/10 divided by 2/5. Now we don't divide fractions, so we do 2/10 times 5/2, which reduces down to 1/2. So the probability of a head given purple is the same thing as what we had here. So that's just a proof of what we just talked about. Notice that probability of A given B is the same as probability of A when A and B are independent. And probability of B given A is equal to probability of B also when the events are independent. So test for independence. Now there are 2 tests. 2 events are independent if the probability of A, the probability of A and B equals the probability of A times the probability of B. That's what we learned the other day. That was our first test. And now, we also know they're independent, that the probability of A given B is equal to the probability of A and B divided by the probability of B, or quite simply, just the probability of A. These 2 relationships work together. If 2 events are independent, then in step 1, we can substitute in probability of A and B, and then these things simplify to what we expect them to be. So now let's write down here just to follow along. Probability of A given B is this formula. We already talked about that. So step 1, we substitute in probability of A times B. And then, since these are the same, they cancel, we're left with this simple statement right there. So let's determine if the missing probabilities, and if the 2 events are independent or not. So A and B is 0.048. A is 0.12, B is 0.5. What is the probability of B given A? Well, the probability of B given A is the probability of both, 0.048, divided by the probability of A, 0.12, which is equal to 0.4. All right, now, since the probability of B, 0.5, does not equal 0.4, then they are not independent. Moving on to the next one. Let's put some numbers in here for the first one, column. So again, we know that A and B is 0.048. So that goes here in the middle. we know that A is 0.12. So this combined circle is 0.12. So if we do 0.12 minus the 0.048, we get 0.072. And if B is 0.5, if we do 0.5 minus 0.048, we get 0.432. Remember, this is 0.12 here, this is 0.5. Also, if we take 0.12 times 0.5, we get 0.06, which does not match the middle. So there's our second way of proving that. They're not independent. So two different ways of doing that. Now over here for B. We have the probability of A and B is 0.2. That goes in the middle. We know the probability of A is 0.5. So if we subtract, we get 0.3. So there's your 0.5 for A. Now the probability of B is going to be equal to 0.2 divided by 0.5, which is 0.4. So we know this is 0.4 right here. Again, if we subtract, that means this is 0.2. Probability of B is 0.4. If we multiply those two, we get 0.2. Therefore, yes, they are independent. Moving on to the last example. A and B is 0.2, so 0.2 goes in here. We know that A is 0.35, so if we subtract, that gives us 0.15 right here. Now we know that A or B is 0.75, so both circles combined equal 0.75. So the probability of B right here is going to be the 0.75, the total for both of them together, minus the 0.35, which is A, and that'll give us the whole circle plus 0.2. That will give us 0.6. So the probability of B is 0.6, which means this is 0.4 right here. So the probability of A given B, remember, is A and B combined, 0.2, divided by the given B, 0.6, which equals 0.33. That does not match here. So the answer is no, not independent. And the last one. A and B is 0.14. We know that B is 0.2. So if we subtract, that gives us 0.06 over here. Remember, 20 cents minus 14 cents is 6 cents. A is 0.7. 70 cents. 70 cents minus 14 cents is 56 cents. So there's 0.56 right there. And if we do 0.7 times 0.2, we get 0.14. So the answer is yes, they are independent. Now, the probability of, since they are independent, that means the probability of B is the same thing as the probability of B given A. So all we have to do is say that these two are the same, and that makes that 0.2. There you have it.